everyone, welcome back to another video. Today we're going to be looking at linear equations that have special solutions. So let's go ahead and let's get started. All the equations we look at today are going to have variables on both sides. So if you didn't watch the video of how to solve linear equations with variables on both sides, you might want to get to that first. If you've watched it, you're good to go. So let's begin. Here we see we have 2c plus 3 equals 2c plus 3. Now this, right off the bat, some of you might notice, well, it's the same exact thing written twice. We're setting something equal to itself. This is a clue that this is going to give us what we call the identity, which means we can actually put in any value for c and still get the correct answer. Now, let's say you didn't spot that. One thing we would do, and we're trying to solve this as a regular linear equation, I would subtract 2c from each side, and the reason why I would subtract 2c is because I would want to get all my variables on the same side. But what we notice happen here is something special. 2c minus 2c gets me 0, and 2c minus 2c gets me 0. The variable canceled out on both sides, and what I'm left with is a statement saying 3 equals 3. Now this is, again, a special type of problem. We call this the identity, which basically means that this has an infinite amount of solutions. It means I can plug in any value to c and I'll get a correct answer. C can be any number on a number line. So because this statement is true, that's why I can do that. 3 actually does equal 3. This is a true statement. Because it's a true statement, that tells me that c can be any value. So I can test it out. I can say 2c plus 3 equals 2c plus 3, and I can test out, let's say c equals 100. That would just mean I substitute 100 for c, so I can do 2 times 100 plus 3 equals 2 times 100 plus 3. 2 times 100 is 200 plus 3, which equals 200 plus 3. So 203 equals 203. You would see this happen every single time for any value that you plug in for c. It's a special type of problem, and this is an example of one where we get an infinite amount of solutions. Okay, so all I would say, I can say the word identity, which would mean that there's an infinite amount of solutions, or I can say infinite amount of solutions. That's two ways that I can answer this. Okay, let's look at the next problem. We got 12b plus 9 and 12b plus 11. So in this problem, if I wanted to solve it and get my variables on the same side, I would simply subtract 12b from both sides. Again, I notice that the b's cancel out on both sides, leaving me with 9 equals 11. Now, unlike the first problem, 9 equals 11 is not a true statement. This is not true. So here we have an example of a linear equation that has no solutions. There's not a single value that I can plug in for b or substitute into it that would actually give me a solution. So whenever you solve a linear equation where the variables cancel out and you're left with a statement that's not true, you're working with an equation that has no solutions. So those are the two special cases. You can either have an infinite amount of solutions, like we did in the first problem, or you can have no solutions, as we just saw in this problem. So these are the two special cases that can happen when we're solving linear equations. If you're solving a problem and you get your variables to cancel out and you're left with a true statement, like you saw in the first example, then you know you have an infinite number of solutions. But if you're solving the problem and then you get your variables to cancel out and you're left with a statement that's not true, like we saw, 9 equals 11, then that means that we have no solutions for that problem. So that sums it up for special cases. I hope this video was helpful. Keep liking, keep commenting, and keep subscribing, and I'll see you guys next time. Thanks for watching.